Guys, this is summer school review sheet for Module 1, Topic 1. I found that since we can't be in the classroom, that this is the easiest way to help you guys get used to what you will need to do. So the notes are going to help you with the quizzes. The quizzes actually help you to get ready for the test. You'll notice that a lot of the questions on the quizzes are on the test. So I do recommend you guys take the quizzes. Okay, very first part is labeling parts of a circle. So just want to make sure you guys know all the words. So very first one we want to go over is center. And I'm going to try and color code it. Center, hopefully you guys all get that one. Center, center of a circle. Okay, next one, radius. Oh, that is really close in color. Sorry, guys. This one, radius, it's going to go from the center to the edge. It can go to anywhere as long as it's going from the center to the edge of a circle. Okay, it can go up, down, left, right, diagonal, whatever, as long as you are starting from the center. Now, diameter is twice the radius. So if you think of the radius as like a bicycle, it's the little spoke that goes from the center of the wheel to the edge. Diameter is going to go from one edge to the other, but it has to go through the center. And it's always going to be double what the radius is. So if the radius was 2, diameter would be 4. Okay, next one is going to be tangent. Tangent is any line that will touch the edge of a circle but doesn't go through it. So if it's going to touch at this point, sorry, I'm not that great at drawing freehand on this one. It's going to touch right there. So that's a tangent. Okay. Oops. Next one is going to be chord. For some reason, I know it doesn't make sense, but for some reason I think of chord as a guitar, the guitar strings. So the strings of a guitar have a starting and stopping point. So I would say a chord on a circle would have a starting and a stopping point. They're going to touch the edge of the circle. It can go bigger, can go smaller. Diameter could be called a chord too, okay? But it's never going to go outside of it, okay? It's never going to go outside the circle. Now, secant, and I have a funny way of saying that. Secant, it can't end. So it is a line, and it's going to go through the circle, touching it in 2 places. It can't end, meaning it has the arrows. It will keep going on and on and on and on. All right, angles. There are 2 different types of angles, okay? The first one is a center. So central angle would be something that goes from the center. Now, an inscribed would be it's in the circle, okay? So it could be this one, this angle, could be this angle, could be this angle. Any one of those, as long as they're in the circle but don't touch the center. Next one is going to be the arc. Okay, it's going to be the arcs. Major, minor. Think of these as in baseball, major leagues, minor leagues. So major means it's going to be more than 180 degrees. Okay, it's going to be more than 180 degrees. Minor means it's less than 180 degrees, okay? I'm just running out of room. So a major arc, if I followed it from here, and usually we'd have letters, but I want to make sure I have the space. The major arc would be something from here to here. That's a major, okay? Minor would be less than 180, so it could be this, just this one. So that purple one, minor. Now, if it was exactly 180, we would call it a semicircle, okay? So that's labeling parts of a circle, which you will need to do. Okay, next one is converse. You will have these on there. Converse just means switch the if and then. That's it. All your stories, all these things are going to have an if and a then. And our converse is always going to have an if something, then something. What we're going to do is just change the if and then. So I'm going to say if we have school, then today is Monday. And ran out of room, sorry. Can't go off the paper. Now, if this is true or false, we have to decide. Our first statement, if today is Monday, then we have school. That is a true statement in a normal day. But our converse is actually going to be false. If we have school, then today is Monday. Well, that could be false because it could be Tuesday, Wednesday, Thursday, or Friday. So it is false for this one. So you just need to think it through. Okay, next one is what are the angles? So what is angle B? So this angle. And what I like to do is we continue that angle to see where it's going to hit the side of the circle. And hopefully you guys know that if an angle is touching the edge of a circle, the arc is twice the angle, sorry. So this arc right here, is half of the circle. So this is 180 degrees. So that means that angle B is going to be half of it. So that's 90 degrees. And the next question is, what is angle A plus angle C? Well, we know a whole triangle is 180 degrees. And if we subtract our angle B, it's going to be 90 degrees. So the other two angles are also going to equal 90 degrees. You can also do it with continuing the lines. So angle A is this half of the circle. Angle C is this part of the circle. And if you add both of them together, it's half a circle divided by 2, you get 90. Next one makes it a little bit easier. So if we want to find out what this angle is, angle AOC, this symbol means angle, okay? So we have to look at what we have and go from that. So what we have is ABC. If ABC is 20, then arc AC must be 40. So this is very similar to what we just did on the previous one. The angle is always half of the arc if it's touching the edge. Now, if it's starting from the center, the arc and the angle are going to be exactly the same. So if they're starting from the center, the arc and the angle are exactly the same. Okay? Now, next one. This is a quadrilateral. Doesn't matter what kind of shape it is inside the circle, anything that had 4 sides. We want to find out what these angles are. Now, the nice thing is opposite angles add up to equal 180. So to find U, we're going to go 180 minus 60, and we're going to get 120 degrees. We can do the same thing with the opposite. Add them up to equal 180, and we're going to go 180 minus the 80 here, and this one's going to be 100 degrees. All righty. Now the next one is going to be kite, square, rhombus rectangle. Sorry, I wrote that one a little long. And isosceles trapezoid. And the big things on these is make sure you just know your shapes and also know which ones have perpendicular. So that's the symbol for perpendicular diagonals. And if their diagonals are congruent. Now, the nice thing is draw a picture if you don't remember the shapes. And these are just going to be rough shapes. Rectangle. And isosceles trapezoid. Be very careful when you're talking about trapezoids because there's going to be trapezoids. There's also going to be isosceles trapezoids on this chapter. And if you don't distinguish between the two, I do have to take points off. So please be careful with this one. All right, for this one, are the diagonals perpendicular, meaning do they make a right angle? So this one, they do. A kite does make a perpendicular. A square will. So it makes a diagonal and it makes a right angle. So it will. And a rhombus will. Think of a rhombus, if you need to, as a square just pushed sideways. Rectangle, if we did it, it's not going to be perpendicular, and neither will isosceles trapezoid. Now, if we look at the diagonals that I drew, are they the same size? So are they going to be the same measurement? The kite is not, okay? The square, yes it is, because if the sides are all the same, then the diagonals are going to be the same. But the rhombus, this side going this side is definitely longer, so it's not going to be there. Rectangle, our diagonals are going to be the same size, and isosceles trapezoid is. But if it's a regular trapezoid, it's not going to be the same size, okay? All right, last one on this one. So we need to decide if I give you three sides, will they make a triangle? Okay, so will it make a triangle? And what you want to do is you want to do three different equations. If they are true, then it is a triangle. So all you're doing is the three different combinations. So is 5 plus 7 greater than 12? Let me put a 7 because my greater than it looks a little bit different. Does 5 plus 12, is that greater than 7? And is 7 plus 12 greater than 5? So we know this one is, yes. 5 plus 12 is definitely bigger. Now 5 plus 7 is 12. 12 is not bigger than 12. So this one is a no because 12 is not bigger than 12. Now if we do the next one, just do a different color. You guys will know I like doing colors, but it does help distinguish it. So if I did 5 plus 7, is that greater than 9? And I'm just going to do it as I go. Yes. 5 plus 9, is that greater than 7? Yeah. And is 7 plus 9 greater than 5? Yes. So this one is a triangle. Okay? And you can do abbreviations. I'm fine with it. So hopefully that's module 1, topic 1. Now I also want to go over nope, I'm just going to do topic 1. Sorry, guys. Review it. Make sure you guys know it. Take the quiz. And then good luck.